Okay, so here is our first section. I hope you guys enjoy the new flipped classes. I promise the videos will get better as we go along. So chapter 4 is all about proofs with triangles. So section 4.1, we're going to learn a little bit more about triangles here. Some of this stuff you guys already know. Other things will be new to you. Anyways, the vocabulary. Triangle. Triangle is exactly what you guys learned in, well, before you even went to school. It's a polygon with three sides. The interior angles are the three angles inside the triangle. Okay, so those are interior angles. Now, the exterior angles, what an exterior angle is when you extend one side out, the angle that it makes with the next side of the triangle is your exterior angle. If you notice, each corner of the triangle will have two exterior angles. Okay? And finally, corollary to a theorem is simply a shorter theorem that follows directly from it. You'll see when we get to the one corollary we're going to do today. Just think of a corollary as the same as a postulate or a theorem when you go to do proofs. They're things that you can use for reasons. Alright, so classifying triangles by the sides. If no sides are congruent, okay, we call that a scalene triangle. So again, scalene, no sides are congruent. If you have at least two congruent sides, that is an isosceles triangle. Okay? And if you have three congruent sides, that is an equilateral triangle. Notice, equilateral triangles are always isosceles. The definition of isosceles is at least two sides. So again, an equilateral triangle is a type of isosceles triangle. All right, classifying them by the angles. An acute triangle has three acute angles. A right triangle has one right angle, two acute angles. An obtuse triangle has one obtuse angle and two right angles. An equiangular triangle has three congruent angles. Notice, an equiangular triangle is also a type of acute triangle. Alright, so let's classify this triangle here. We'll classify it by the shape and by its sides and its angles. Now, since it has one pair of congruent sides, we know that that is isosceles. If we were to measure the angles, we would see that the angles are 72 degrees, 72 degrees, and 36 degrees. So if we put that together, we have an acute isosceles triangle. Alright, so now go ahead and do check number 1. Pause the video till you're done and then you can check your answers. Okay, so draw an isosceles right triangle. Now, if you remember from right triangles, the hypotenuse always has to be the longest side. So if it is isosceles, okay, we have to have two congruent sides. Those would have to be your legs that go around the right angle. So your isosceles right triangle would have to look something like that. Now, for our obtuse scalene triangle, obtuse means that we have one angle bigger than 90 degrees. Scalene means that we have three different side lengths. So it should look something like this. Okay, notice all three side lengths are different and we have at least one obtuse angle greater than 90 degrees. Okay, moving on to example 2. Now, in this one, they were nice. They drew us a picture here. You're going to have some problems on your homework where you just get the coordinates. Well, when you're given coordinates, automatically think distance formula and slope. So let's classify it by its sides, then determine if it's a right triangle. So let's start with the sides. They've got a graph here for you, so you can look at the picture. What I want you guys to do is use the distance formula and find those three lengths. Go ahead and pause the video while you solve for those. Okay, so here are three side lengths. You'll see that RT is the square root of 52 units long. Whoops. Sorry about that. Square root of 52 units long. RS is the square root of 65 units long. And ST is the square root of 13 units long. Notice I didn't reduce those because I just wanted to see if they were the same or different. Since all three sides are different, this would be called a scalene triangle. Now, let's think about what it means to be a right triangle. If it is a right triangle, that means that we would have two sides that are perpendicular to make a right angle. Those would have to be the two shortest sides. The two shortest sides are RT and TS. So let's see if that is a right angle, if those two sides are perpendicular. Okay, so let's start with the slope of RT here. You could count on the picture, or if we use the formula, we get -1 minus 3 for the difference of our y coordinates, 3 minus -3. That reduces down to -2/3 for the slope of RT. For the slope of ST, we've got -1 minus 2 for the difference of the y's, 3 minus 5 for the difference of the x's. That gives us a slope of 3/2. Notice those two are opposite reciprocals of each other, so their product is -1. So that means that RT is perpendicular to ST. So angle RTS is a right angle. So if we put all that together, we can say that triangle RST is a right scalene triangle. Okay, go ahead and do checkpoint number 2. Remember, to classify it by its sides, you have to find all three side lengths. To determine if it's a right triangle, take the two shortest and see if those two sides are perpendicular. So go ahead and pause your video while you figure that out and check your answers when you're done. Okay, so here's our three side lengths, JK, KL, and JL. You will notice that JK and KL are congruent. So it is since we have one pair of congruent sides, it is an isosceles triangle. Also, notice the slopes of those two sides, the two shortest sides, JK and KL, are 4/3 and -3/4. They are opposite reciprocals. So we have got a right isosceles triangle. Again, we know that it is isosceles because of, I kind of ran out of room there. It is isosceles because the two side lengths are congruent, and we know that it is a right triangle because we have two sides that are perpendicular to each other. Okay, Triangle Sum Theorem. This is a basic one that most of you probably came into class knowing. If you take any three angles in a triangle, they will always add up to 180. The proof for this is really easy. If you take any triangle, okay, we'll call it ABC, draw the line that is parallel to AC through point B. Okay, so we got two parallel lines. Now, if we treat sides AB and BC as transversals, then we have some alternate interior angles. We know that these two angles are congruent. We know that these two angles are congruent. The third angle of the triangle there completes our 180 degrees for that straight line. So again, there's all three angles add up to 180 degrees. All right, corollary. Remember, a corollary is something that follows directly from that. Well, if all three angles of a triangle add up to 180 degrees, and we know that we've got one right angle, 180 minus 90 is 90. So the corollary to the triangle sum theorem tells us that whenever we have a right triangle, the two acute angles, the two smaller ones, are complementary, add up to 90. If you ever have to use these in a proof, you can abbreviate it triangle sum theorem or corollary to the triangle sum theorem. Okay, those two have names, so you can use those names. All right, the exterior angle theorem. This one kind of follows from the triangle sum theorem too. Notice, we know that angles A, B, and I'm going to call that angle 2. So the measure of angle A plus the measure of angle B plus the measure of angle 2 equals 180. Well, we also know that angle 1 and angle 2 add up to 180. Okay? So, if we take away angle 2 from both sides, we end up with angle 1, our exterior angle, equals the measure of angle A plus the measure of angle B. So, whenever you have an exterior angle, in this case, angle 1 is our exterior angle, it will equal the sum of the two remote interior angles. Okay, so here's a pretty simple example that uses that. Here's our exterior angle, 3x minus 9. And then we've got our two remote interior angles, the two that don't touch it, are x and 73. So using that exterior angle theorem, 3x minus 9 will equal x plus 73. It's just a quick bit of algebra, and we'll get x equals 41 degrees. Now, they didn't want x, they wanted the measure of angle DCB. So, if we plug in 41 for x, remember angle DCB was 3x minus 9, we get 3 times 41 minus 9, and that is 114 degrees. So the measure of angle DCB is 114 degrees. All right, now it's your turn. Go ahead and solve this one, and I'll give you a few seconds. Pause the video and let me know when you're done. Okay, so for this one, they want us to find the measure of angle 1. If we look, we've got our exterior angle here is 3x plus 16, and that is equal to the sum of the two remote interior angles, 2x plus 52. Subtract 2x from both sides, subtract 16 from both sides, and we get x equals 36. Now we need to look at the actual question. The question here is find the measure of angle 1. There's a couple ways you can do that. I think the easiest way is to find the exterior angle, the measure of angle DCB. Okay, and so we've got 3 times 36 plus 16, and that gives us 124 degrees. Okay, so I know that this angle is 124, and if I look, angle 1 is the supplement of that. So the measure of angle 1 is going to be 180 minus 124, which gives us an answer of 56 degrees. And that is our final answer there. That is the measure of angle 1, 56 degrees. All right, last couple examples here. So here we've got a wheelchair ramp, and it says that one of the angles is 8 times as big as the other one. So if we go ahead and sketch out a picture, we've got one angle 8 times as big as the other one. So in our picture, one angle will be x, the other angle will be 8x. And since this is a right triangle, we can use the corollary to the triangle sum theorem to tell us that those two angles are going to add up to 90 degrees. So x plus 8x equals 90. Simplify, that gives us 9x is 90, divide by 9, and x is 10. So the measures of our angles are 10 degrees and 8 times 10, or 80 degrees. Okay, so last checkpoint here. What would be the obtuse angle formed between the ramp and the segment extending from the horizontal leg? So you should be able to do this one pretty easily in your head. It's mostly just to see if you understand the vocabulary. So give you a second to answer that. All right, so let's make sure that you're thinking of the right angle. So we had our ramp here, and we just figured out that we had our right angle. This was 80 degrees, and this was 10 degrees. The angle that they wanted, it says the one extending from the horizontal leg. So that would be this angle here. It is a supplement to the 10 degrees, so it is 170 degrees. And that's it. Hope you enjoyed the lesson, and we'll do some more work on this tomorrow in class. See you tomorrow.